Hi, Nicole here, and welcome back to Stem Cell Talks. In our past videos, we have brought you exciting news about human clinical trials involving dental pulp stem cells, or DPSCs. However, in thinking about these human clinical trials, it's important to remember where they all begin: in the laboratory. So today is the first part of a two-part Stem Cell Talks update where we are going to report on several initiatives that researchers have undertaken utilizing DPSCs to explore treatments for a variety of diseases and ailments. The studies that we will be discussing today include those for the treatment of Sjogren syndrome and Pulpitis. Let's start off with the Sjogren syndrome study. Sjogren syndrome affects approximately 4 million people globally and is a degenerative autoimmune disease in which the body's immune system attacks saliva glands, tear glands, and other exocrine glands. As of now, there's no cure, and the treatment for Sjogren syndrome revolves around symptom management to offer some relief from the dry eyes and dry mouth that this disease causes. Seeking to address the flaw in the immune system that causes Sjogren's and holding a strong understanding of the immunomodulatory characteristics of DPSCs, researchers from Turkey injected DPSCs into animal models with induced Sjogren syndrome to assess their ability to modulate the defect in the immune system. It was found that after the DPSC injection, lymphocytes, which are overactive in those with Sjogren syndrome, attacked healthy cells at significantly decreased rates, as evidenced by a decrease in the number of lymphocytes in the spleen. It was also found that those receiving the injection showed an increase in regulatory T cells and cytokine levels, both of which possess anti-inflammatory properties. Last but certainly not least, the ability of the DPSCs to differentiate into glandular tissue helped replace the damaged glands caused by Sjogren's, which was evidenced by an increase in saliva and tear production. Next up, researchers from Hong Kong University have explored potential uses for DPSCs as a treatment for pulpitis. Pulpitis is a dental condition in which the dental pulp, or the innermost tissue of the tooth, becomes inflamed. In order to treat pulpitis, the inflamed tissue must be removed and the tooth must be filled with artificial inert materials. This is commonly referred to as a root canal and typically results in a dead tooth. In fact, it has been estimated that about 25 million root canals are performed each year. To keep the tooth alive, stem cell researchers have attempted to use DPSCs to regenerate the pulp instead of filling it with inert material. But the lack of a blood supply, resulting in low oxygen conditions in the root canal, made this a challenge. Seeking to address this issue, researchers modified DPSCs from human exfoliated deciduous teeth, or baby teeth, to better survive the low oxygen conditions in an empty root canal. They then implanted the stem cells into the empty root canal of human teeth. The modified stem cells demonstrated both a higher survival rate and improved vascularization. The study points to DPSC's potential as an alternative treatment option for pulpitis. More importantly, the treatment would result in keeping teeth alive, always a better alternative than dead. As we have been reporting, and as many of our viewers understand, DPSCs have many unique properties that researchers are taking advantage of as they develop stem cell treatments. These properties include high levels of plasticity, that is, the ability to differentiate into many types of tissue, high proliferative rates, that is, the ability to regenerate rapidly, resulting in a high yield of cells, and their accessibility and ease of recovery. These properties make them prime candidates for treating a broad range of diseases, trauma, and injury, and are evidenced by researchers expanding the use of DPSCs in animal studies and clinical trials. We will continue to update you on the progression of these studies. Thank you for watching. Don't forget to like and subscribe, and we'll see you again soon.